So with a bit of luck, we are now online, and it's my pleasure to wish you all welcome to this 5G Global Outlook webinar hosted by Telenor Connexion. My name is Martin Whitlock. I am the CTO at Telenor Connexion. I also have with me today Jelte Jansons, who's a product manager for IT here at Connexion. We are planning today to go through the, first of all, outlook of 5G with a focus on the enterprises and what are the real implications for enterprises to consider when it comes to 5G. But before we start, I'd like to highlight also that for those of you who watch this live, there's a possibility to post questions in the chat function. So please do so, and we will try to address as many of those as possible at the end of this webinar. But it will also be available afterwards for those of you who are not watching live. All right. What are the real implications for enterprises when it comes to 5G? I'm sure that many of you have been following in the press and read about 5G. I guess if you're not into the details on a daily basis, there could also be some confusion and questions with regards to what it actually is and how it affects you as an enterprise, potentially then also looking into IT applications. And that is why we are here today, trying to give some perspectives from our side on this and approach it from both what is 5G actually, how will it be used, and potentially also when can we start to use it. Because at the end of the day, we know that many of you are considering IoT technologies and want to know what to relate to as of today and also to be fit for the future. But before we look into the future, let's look a bit backwards. I think many of you can relate to these generations of mobile networks that we've had over the decades. And as you can see, there's more or less with a 10-year cycle an introduction of a new technology within the mobile industry. And 10 years, for that sake, is a very long time for mobile operators, but maybe not so long for enterprises producing goods that want to have them connected. So it's important to keep these time aspects when you design your solutions. I think starting maybe with 2G was the first technology that hit the market mass scale, designed for voice and messaging and those simple services, but also used for some IT related things like telemetry, we call it then, and moving into machine-machine. But now we're in Internet of Things era, and actually 5G is the first technology out of this you see here that is having the Internet of Things use case as part of the design pattern from start. So we've been using technologies for these services in the past, but it's been a bolt-on for on networks that were actually designed for other services, other types of communication. But now with 5G, we introduce things like critical communication for IT. We have mobile IoT solutions like LTM and Airband IoT, which to some extent are working already for 4G, but definitely part of the 5G era as well. And actually, with that introduction, I will hand over to my colleague here, Jelte, who will continue to guide you through this presentation.
Thank you very much, Martin. And my name is Jelte Jansons, and I will talk about what 5G is. And we mentioned there is some confusion in the market because 5G consists of 3 different things. And the first thing is actually mobile IoT. That is a smarter way to use the Internet of Things. So we can make a connection and we can use this connection to get a battery life of around 10 years and very good deep indoor locations coverage. Where that is possible because we are giving less things, so the device is doing less. And this is a little bit confusing for many because most of us, when thinking about 5G, we think about more. This is a traditional message, also part of this generation of the connectivity, that it will be more and we will get more bandwidth in cities, but also in rural areas. And it will be faster. A fast and secure immediate response is very important. That enables many use cases. And both the mobile IoT and critical communications are technologies specially designed for the Internet of Things. Whereas enhanced mobile broadband is primarily designed for consumers, but now enables also very many new innovative IoT use cases. Let's first have a look at the mobile IoT. Less is more. A longer battery life of 10 years without charging is possible by using less radio. This enables use cases like sensors in buildings that have a life cycle of 10 years, but don't have access to power. But it also enables a little bit other use cases. For example, having a battery life of 1 week instead of having to charge every day can already change a lot. For example, 1 week might be a very good way to trace assets that are without power for a week, and then after a week perhaps get power again. So it doesn't have to be so extreme as this 10 years. So this is a matter of tuning and tweaking, and we will come back to that later. It also gives better indoor coverages, specially designed to work underground parking garages and in cellars, for example, for smart meters. And it's efficient. It's if you make it a little bit, I like to simplify sometimes too much, but this is a normal consumer phone. It has 2 antennas and a lot of hardware. Strip out an antenna and remove a lot of hardware, and you have a very efficient design, which especially in mass production produced can give a much better module prices than regular LTE. So here we believe this mobile IoT is an important part of the 5G family, introduced during the 4G area. So you could say it's 4.5G, but the important thing is that this is 5G compatible, and we will look how this is 5G compatible later on in the presentation. Ericsson already says 52% of the use cases in 2025 that are cellular, they will use this technology. We believe also very much that a lot of use cases, especially those that are still on 2G and 3G, will move to the mobile IoT technology using LTE-M or narrowband IoT. Enhanced mobile broadband is the first thing where consumers, so what the general public is thinking about when it comes to 5G. It's mainly more. More video streaming is one of the use cases. In this troublesome time of the COVID-19 crisis, we have seen a drastic change in usage patterns. Before the crisis, how was usage pattern? People were surfing the net, they used the data to read their mails, and perhaps they sent some messages. And we used one data stream. For example, we were watching a movie, we were downloading something. That was the behavior. But now what we see, what happened now, that everybody starts to remote working. So there's massive streaming. So that's a consumer kind of use case, but this kind of massive streaming also enables things like remote maintenance. So remote maintenance is going to become more important and easier to do with the 5G globally and while on the move. Let me give a practical example. This lady on the picture here is an expert of a specific machine. She has the expertise, and there are quite a few people, there are not so many people that have this expertise. The machine is located in Spain, while she is in Sweden. Before COVID-19, she would fly to Spain, repair the machine and fly back. But now, due to travel restrictions and also health matters, the situation changes. She could use a video stream working together with a local Spanish colleague, and together inspecting the machine, she can give detailed instructions to this local worker what to do, or perhaps even remote control it to do this kind of repairs. So video streaming is going to be more and more important, because we believe that even after the COVID crisis, once people start to use video streaming on a larger scale, this will just only continue. So this kind of use cases, remote maintenance, for example, remote working, having things like video streaming in, for example, customer support in a shop, or will actually just only increase. So enhanced mobile broadband is for massive streaming where people cooperate with the Internet of Things. So when you have people that are working with other people or people working with machines, then this streaming is very important. Critical communications is to make things faster, and where it is actually made where machines are working together. Let's take a look at the example of self-driving cars. Self-driving cars on the public road need very fast communication, so they can warn each other if there's a problem, or they can actually automatically start braking, or autonomous driving is there. So there is a lot of use cases that are about autonomous driving on public roads. But many of these use cases we find that people are talking about, they are quite advanced. And driving on the public road, self-driving cars, that is actually not just technology. There's much more needed than technology. So it's perhaps better for us working as enterprises today to think about what is the kind of use case that is not so advanced, but actually really good for critical communications. And that is closed industrial environments. With two examples here. On the left-hand side, you see a container harbor. And in this container harbor, there are cranes. They lift containers from ships and put them on trucks. It's a closed industrial environment where it's very important that this goes fast. The second example, here we see several robots working together to make a finished product. And these robots, they communicate with each other. They need very fast communication so they can do the production just right. You understand, this must go very fast, and it should be very reliable, because if the production stops, it's very expensive for the manufacturing company. But it's not life-threatening. So the self-driving cars, that is more an example where you have also other aspects. The first use cases we think that will happen in the critical communications are these closed industrial environments where machines are working together. See how nice these different robots sit together, building together a finalized product. There where you need massive streamings, where machines cooperate, there comes the critical communication. So that are the three different aspects. Well, we are of course also can look a little bit from an engineering perspective. What is it? How does it work? And I think that's always good to look at from that perspective. If you understand on a high level how the technology works, you understand how it fits better, what you can do with your use cases, and how it fits in the complete telecommunication landscape. So the 5G mobile IoT is about longer battery life, and we do that very simply by laziness. That's often what I think is the best thing, right? If you want to have a long life, what should you do? You tell that to your children: sleep more and do less. Yeah, that is exactly what we do with radio. So the devices, they go to sleep mode, so they don't send so much radio. But you understand there is a disadvantage of that. If you do that and you put a device to sleep mode, then it's not very responsive. You know, I would like to take a nap right here, and I feel, I have slept during the live stream. Fantastic. I am full with energy. I come out of the live stream a full battery, but for you, the audience, would not be so nice because I am not have a good responsiveness. So it's the same for your IoT devices. Then the better indoor coverage is done by automatic repetitions, but also by tweaking the radio signal, making it a little bit stronger or less strong under certain radio conditions. So what is the smart thing about this? That it enables you as the IoT developer, as the company that are deploying IoT devices, to find the right balance between how fast must it be and how much battery do you save. Sometimes by tweaking a little bit, you can already save a lot of battery without losing all the responsiveness. Enhanced mobile broadband, that is introducing new radio bands on a high frequency, but also there are many antennas here that working together in the system at the same time. And what is happening here is beamforming. What beamforming is that radio signals are being sent to a specific device instead of that is sending to all devices in the cell at the same time. So it brings a direct relation, let's say in the radio, between the tower and the device. Because we use high frequencies, we have then problems in cities with buildings, as you can see here in the car, and these buildings are in the way on the right hand side. So what we need is a lot of small cells here, a lot of extra towers, perhaps smaller towers that are closer to the cars, so that we can have good mobile connectivity. Now the good news is that you as an enterprise don't have to care about that. It's a headache for the operators. The devices, they will not notice, they will just go to the different cells, and that handovers will go very smooth, because that's how the mobile network always is designed to work. The final thing, critical communications. Yeah, you need to think about the speed, and the speed, of course, how fast can we make it? Well, the speed of light is the maximum. If you can do it better, then please call us. 300 kilometers in 1 millisecond. So if you need a response of 1 millisecond, then you need to make sure you are quite close to the cloud. Now, a lot of enterprises have put their data from local data centers into central clouds. That has been going on, and I think most of you have actually put data in clouds. But if you want to have a very fast response, your architecture needs to be redesigned, and a decentralization of data, communication, and computation is needed. So it's not just put in a SIM card and it works. You also need to consider there are two parts. There is a part which is local. So you have a local side with a local radio network, a private radio network, you could say. And the robots there on the machines, they have very fast connectivity because all the data stays there. Then there's, of course, still a central cloud. The central cloud is not replaced by edge, by the local side. No, the central cloud is, of course, there. And the central cloud is good for most use cases. And why should you put data in a central cloud and not in a local side? The reason to put things in a central cloud is, of course, cost. And it's much easier to scale on a central cloud. That's why we have moved to the central cloud. But for those use cases, you need a fast response, and you don't want to share all that data to the central cloud for security reasons, then you can use an edge. So this is the edge technology used for critical communications. Well, it's a lot of information. I can understand that you then think, yeah, when can we start using it, right? Well, we have here a forecast based on our experience of the industry. We have been in this industry since the 1990s. Of course, this is a forecast. We do not guarantee, of course, what will happen in the future, but we already know that the mobile IoT is available today. So the mobile IoT is connectivity technology, part of the 5G family, available today. And also it's already available globally, starting with a few roaming partners, which will be extended during the coming year. Massive streaming, this enhanced mobile broadband, it needs new radio auctions in many countries. So we see that in Asia, enhanced mobile broadband already there, parts of the United States, I believe also enhanced mobile broadband there. In Europe, we're a little bit behind. There are still auctions going on and have been there. So the first deployments are around 2020, and globally they will be available. And that means that there will be roaming, will be working 2023, around that time we expect. But the critical communication will take more time. That's because the standardization of the critical communication has just been finalized. And that means that right now we are in piloting phase. So it's a very early days for the critical communication and the edge technology. We got a question in the previous webinar about LTM and narrowband and 5G. So we say that LTM and narrowband are supported throughout the life cycle. How does that then work? Well, in the beginning, you can say that all the 5G deployments that are deployed right now are in so-called dual mode or non-standalone, as they call this. That means that it's like the first electric cars have two engines, right? The petrol and the electric engine. Now, this 5G dual mode is using the 4G LTE as first technology, as the anchor technology. That means that 5G devices first will connect to the 4G and then say, I would like to use 5G, they get redirected to 5G. So 4G is still there. So the LTM and narrowband IoT can use that 4G on those lower frequencies. When 5G standalone is there and we have only the 5G new radio technology, There might be no 4G LTE according to the standardization, but we believe very much that LTE will be around for a very long time to come. And even if it would not be that case, then LTE-M and narrowband IoT are exactly designed to work in that 5G new radio as in the exactly time slot. It's really designed for that. So LTE-M and narrowband IoT are future-proof technologies for the 5G. What are actually the real implications for enterprises are there? Perhaps Martin, could you
try to summarize this?
Yeah.
Yeah, it's a hard thing to do, to summarize this. It was a very good presentation, Jelte. But if you want to take a few takeaways away with you, I think that the first one is that 5G is starting to be deployed pretty soon, but the first use cases that will be in focus will be the enhanced mobile broadband, meaning that operators will likely focus on the urban areas to roll out 5G to get more capacity for the mobile broadband use cases and support consumers and the professionals that want to use their handsets to a larger extent. That said, this will of course also open up for additional use cases for IoT. For instance, within the frame of video streaming and such things, which Jelte talked about. But maybe the rollout patterns will be urban areas first and then spreading it out to the rural areas. The second point is that critical communication and 5G edge, that's potentially still in the piloting phase and also partly realized with private LTE networks that will evolve into private 5G networks and so on the edge. I think that this will open up brand new use cases for mobile applications. It will be enabling factories in an industry 4.0 type of manner to be automated using the help of cellular communication. But also something that will be added on top of the 5G rollout plans that we see today. The third and maybe the most important takeaway, at least for those of you who consider to implement IoT technologies in your products today, is to consider the mobile IoT. And here we have LTE-M and narrowband IoT, which are part of the 5G era, but specified to work on top of today's LTE networks as well. So it's an excellent bridge between applications that can start to work already today, but also live on into the 5G area and thereby be future-proof. And of those two technologies, LTE-M is the one that we see as best fit to replace existing solutions on 2G, 3G, whereas narrowband IoT open up for maybe additional, even more extreme use cases, but with limitations in terms of responsiveness and so on. Those are the three things we think that you should be taking away. But that said, I suppose that there are also some questions that have been posted in our chat function, which we will try to answer. I think maybe the first, Jelte, you can respond to what are the use cases you see that are enabled specifically by 5G?
Yes, so in the 5G is the first cellular technology that is really made for the Internet of Things. And there are actually two things. It's a mobile IoT that you can have a battery life of around 10 years, something that is not possible with regular LTE. But also when you look at critical communication, the ultra-fast response. But in general, the enhanced mobile broadband bandwidth can make certain use cases we do already now much better. For example, I have here in front of me a picture of 4 faces and they're not moving. That's because the bandwidth we're having here is limited. Just imagine in the future we enhance this into a virtual reality where we have those, where I can actually see you in the room and I can interact with you, because you know that's the hard thing for us as presenters here. If we don't see your faces, you know, what we say and what you ask us is only a very small part of the communication. So it will enrich in many different aspects. And I see there is another question. What are the differences between LTE-M and narrowband IoT? the differences are they are both mobile IoT technologies, so they are both, let's say, supported by operators. LTE-M is more fit for as a replacement technology for use cases that are now on 2G and 3G. If you just look at the amount of bandwidth that you can do, but narrowband IoT is really designed to be as efficient as possible, to have the most efficient network usage as possible, where LTE-M is, you could say, a narrowed down version of normal LTE with a similar kind of mobility. And it's very difficult to answer that in 1 second, but please go to our website. We have a white paper and more information where you can read more details about the differences. And then I see another question. Will 5G replace 4G? Martin, perhaps.
Yeah, that's of course a very important question to ask. I would say spontaneously no. That is also based on, if you look back, you can see that we still have technologies like 2G around. Why do we have that? Well, partly it's our industry's fault, actually, the IoT industry or M2M industry, because we have a bunch of installed devices. I would be bold and say that maybe still the majority of the live M2M applications are relying upon 2G coverage today. So for that sake, it's very hard for operators to just cancel the 2G coverage, although I know that many would like to, because the spectrum efficiency that are introduced with new technologies, opens up for brand new utilization of the spectrum. The spectrum is a natural resource, so it's scarce in that sense. But then looking at the frequency bands that we are currently using primarily for 4G, it's in relatively low frequencies, meaning that here is not where 5G as a concept with the beamforming and all that will make the biggest difference. It's actually up in the higher frequencies. So from that sense, 4G is still rather efficient actually in the frequency bands being used today, while 5G opens up for the additional frequencies higher up. So I think also Jelte mentioned this in his presentation, that 4G will be used as a base layer for coverage and for communication for a long time, but it will also continue to live within the 5G area for a long time. So it will not replace 4G per se, but they will live in symbiosis for quite some time. I see there's a similar question here. Will 5G replace Wi-Fi? What do you say, Jelte?
Yeah, Wi-Fi, of course, is the connectivity technology that is used to connect most of the IoT devices. And some people might say, okay, 5G replaces the need for Wi-Fi, and we think that's not true. Wi-Fi is a very good technology you use when you have a local situations. For example, you have connectivity inside one building, and you can manage the connectivity yourself. Mobile technology like 4G and 5G is able to get you a managed solution. That means that in a central way we can help you to monitor the network, so it's always somebody monitoring with IoT expertise monitoring the network. You can also make sure that your devices work everywhere, so not in one building but in all the buildings in a city, or all the cities in a country, or all the countries in the world. And that ecosystem is existing, so that is for very different kind of use cases. So together those technologies will enrich each other, we believe very much. And I'm just looking here at the time. Do we have a time for an additional question? I think perhaps there was a question about the better indoor coverage. How about steel walls? Can you explain a little bit about that, Martin?
Yeah, steel walls. I'm not an architect in that sense, but modern building of houses includes a lot of steel, as we know it, and those of you who have a degree in radio communication knows that steel cages are equal to a Faraday's cage, which effectively blocks radio signals if it's built in a bad way. This means that the indoor coverage, of course, becomes even more relevant when it comes to new buildings. That said, what 5G does is to have this beamforming compensating a little bit for the really high frequencies that are being used. The higher frequency, the shorter the range normally, but beamforming compensates that and concentrates the efficiency in one direction. So actually, that is the reason why we can still use the high frequencies, even though we want good coverage. But with that, I think that time is up. If you have further questions, don't hesitate to reach out to your closest Telenor Connexion representative or visit our webpage. And we really thankful for tuning in to this session today. So thank you very much for that.